Hi again. Well, we're continuing our work with probability, and this whole video is a practice problem. So if you'd like to, you're welcome to try it. Stop the video, try it out, and then come back and check your answers. Or if you're not ready for that yet, we can do it together, and then you can practice on the homework. Okay, so we have a different table here, but it's again a two variable categorical table of data. So it says, how are the smoking habits of students related to their parents smoking? And I think parents should have the apostrophe at the end. Here is a contingency table of data from a survey of students in 8 Oregon high schools. Okay, so in the rows we have the student smokes or does not smoke, okay? So that was one piece of information gathered about these students. And then we have 3 different columns. Either 2 parents smoke, or 1 parent smokes, or no parents smoke. And then the total column and the total row, okay? Of course, people could have more than 2 parents as well. So I don't know if that was studied or not. It doesn't seem to be on the table here. So student smoke, so probability student smoke. So if it's helpful to you, also write down what type of probability. Is it a marginal, joint, or conditional? Okay, so I'll write that for each one. Student smoke, so that's only one characteristic, right? So this is a marginal. And notice the probability statements are all written out for us. They could have been written in words, but if the problem is written in words, then please do write your probability statement. That helps in case something goes wrong. Okay, we know what you're trying to find. So probability student smokes. Let's look for all of the students in here that smoked. And so they're not saying anything about the parents. So we're going to go all the way over to the total of 1,004 out of 5,375. 1,004 over 5,375. Let's go ahead and calculate what that is. 1,004 divided by 5,375. 0.18679, so 1868. 0.1868. Okay, so if one of the students was selected at random, 18%, we could say 18.68% of the students smoke. Now, I'm also not sure if this is just smoking cigarettes or if it's smoking other things. Don't have the full context on this, unfortunately. Okay, what's the probability that none of their parents smoke? Okay, so again, this is still one, only referring to one variable. Now it's just the parents, not saying anything about whether the student smokes or not. So this is also marginal. Neither or none of their parents smoke, so that would be the total of 1,356, the total of the no parents smoke column. So that's equal to 1,356 out of 5,375, our grand total. $1,356 out of 5,375.252, and I'm 27, so I'm going to round that to a 3. 2523. Okay, so then I'm going to say 25.23%. These are all students, right? But these are students where none of their parents smoke. 23.25% of the students have no parents that smoke. Okay. At least one parent smokes. So Now we need to think about this. Student, student. So students are in the rows. So we're in the columns. We have 2 parents, 1 parent, and no parent. So sometimes we need to combine rows or columns. At least one, in this case, is going to be 1 or 2, right? So this is kind of an or probability in disguise, but because they're 2 columns, they're disjoint. There's no overlap. So we can go ahead and add those together. So these are disjoint. So we can add. Okay, so at least one. Again, we're in the total, we're in the marginal. I'll put marginal as well, because we're only talking about the parents. We're not talking about the students themselves. So this would be 1 parent or 2 parents smoking. So 2239 plus 1780 out of 5,375. Let's see what we get here. 2,239 plus 1,780. Hit enter. I get 4,019 divided by 5375. And that is 74.77 or 0.7477. 0.7477. Seems high to me. That's interesting. Okay, so 74.77% of the students have, I'm going to say 1 or more, but at least 1, or I can just phrase it like the question, have at least 1 parent who smokes. Okay, I think it's time for a new color. Letter D, what's the probability the student smokes and 1 parent smokes? Okay, so now I see an and in here, so that's a joint probability, joint or and. Okay, so joint or and, those are in the interior of the table because those are the intersections. So student smokes is our first row, and we're going to go across until we get to 1 parent smoking. And so the intersection there is 416 out of our grand total of 5,375. So this is 416 out of 5,375. Let's see what that is. 416 out of 5,375. 0.0774. Okay, smaller, because when we do an and, when we add conditions or add multiple categories, it gives us a smaller number, right? Smaller number of people in the intersection. So this is 7.74 of the students smoke and have 1 parent, so exactly 1 parent who smokes. Okay, now we're going to get to letter E, and I see an or in here. Probability that a student smokes or no parents smoke. Okay, so either the student smokes or none of their parents smoke. So this is an or probability. Remember what we have to do with this one? And this is adding up multiple possibilities, because the student smokes, we have 3 possibilities, right? 400, 416, and 188. And also, we also want to count the people who do not have parents that smoke. So we've already counted the 188, so that's the 1,168. Okay, so I'm going to do it the addition way first, and then I'll do it the subtraction way also. Okay, so the addition way would be 400 plus 416 plus 188. So that's student smoking. Or, so either or, 1168. And all that is out of 5,375, the grand total. Okay, so 400 plus 416 plus 188 plus 1168. I'm going to go ahead and write the total here because there's so many ways to get this total. 2172 out of 5,375. I'll go ahead and divide it though. Divided by 5375 is 0.4041. Okay, so remember we had different ways of doing it. So I wanted to just show you another way. The other way was the subtraction way, where we're in student smokes or no parent smoking. So I've already got both of those totals circled. So if we use the two totals, then we need to subtract the intersection of 188 because the 188 is in both the row column and the total column. So we can also try adding, let's see if it comes up to the same number we got. If we add the two totals, 1356 plus 1004, we would need to subtract the 188. And did we get the same thing? Yes, we got the same total that we got by adding. So there's several ways to do that one. You can choose any way, any of the ways you like. Just show your steps so I can follow it. Okay, let's see if I can squeeze this in here. So 40.41% of students either smoke or none of their parents smoke. So, or both, because both is also included in that. Sometimes the or statements are kind of strange. Okay, let's see what letter F says. What is the probability? So notice we don't have a probability statement. Now we're working with words. What's the probability that a student who smokes has no parents that smoke? Okay, probability that a student who smokes. So this is actually a conditional because they're giving us a piece of information. They're saying only look at the students who smoke. So this is a given or conditional probability. So let's write out our probability statement. Probability that, and the probability we want is that no parents smoke. So I'm going to say no parents smoke, given, and if you're typing, this vertical bar is on the keyboard. It's usually right above the enter key, and you have to hit shift to get it. So it is there if you're typing. Probability that no parents smoke given the student smokes. So I'm going to put student. Student smokes. Okay, so remember how this conditional limits it to a one row or one column. So I'm going to write my denominator first. So we're only looking at students who smoke. So that is this first row, students who smoke. So I know my total is going to be out of 1004. And then within that row, it's too far, within that row, how many have no parents smoke? That's 188. So 188 out of 1,004. Let's calculate that. 0.0938. Okay, now when you're wording these, be a little bit careful because we have to convey the condition in the wording, right? Versus like the and, where we said 7.74 of the students smoke and have one parent who smokes. So we couldn't use and in here because that would be a different probability. But we could say of the students who smoke, right? We could say 9.38% of the students who smoke have no parents that smoke. Okay. Okay, two more. We're almost there. What's the probability that if two parents smoke, their child will smoke? And this is empirical, right? Remember, it's just given this data set. Don't know how representative this is of larger populations. What is the probability that if, so if, that's conditional, right? If two parents smoke, their child smokes. Okay, so the conditional goes second, the probability goes first. We want to know the probability their child will smoke. So I'm going to say student smokes given two parents smoke. Okay, let's look at which row or column will we be using. So if two parents smoke, so we're only looking, is that a row or a column? Two parents smoke, that is a column. So I'm going to outline it in green. Okay, since I don't have any of this column highlighted yet. So two parents smoke, that's a column. So I know that it's going to be out of 1,780, that column total. And then how many in that column have the students who smoke? And that's 400. Okay, so that's 400 out of 1780. So I wrote that down here, 400 out of 1780. I'm going to calculate that. 400 out of 1780 is 0.2247. Okay, I've been borrowing space, so let's see if I can fit this in here. So this is if two parents smoke. So 22.47% of the students with two parents who smoke also smoke. Okay. Okay, my screen disappeared there for a second, but I think it came back. Okay, so we found a whole bunch of probabilities. We found actually 3 marginal. One was a combination. It was adding some together. Then we had 1 joint or and, 1 or, and 2 conditionals. Okay, so good practice. Now, I bet we're going to have an independence test. Next, does student smoking seem to be independent of their parents smoking? Show your test and explain your conclusion. Okay, what do you think? Do you have a guess? Do you think it's going to be independent or dependent? Okay, so now that you have your guess, let's look at our table and decide which way it makes more sense to analyze this. Okay, so in the one with 3 different treatment groups, we looked at the success rate in each group, right? So here we could either pick the students who smoke or do not. Okay, I think for me it seems kind of logical to pick the students who smoke, and then we'll compare that across 2 parents, 1 parent, or no parents. Okay, so this time we're going to go down versus last time we went across. So it can go either way. So this time I'm going to go student smokes out of the total, or student smokes out of the total of 2 parents smoking. Okay, so let me write it out and get a different color. Okay, so I'm going to write it out as 400 out of 1,780. So that's the total of 2 parents smoking. And I'm going to do a, is this approximately equal to, question mark, 416 out of 2239. That's student smoke given that 1 parent smokes. Is that approximately equal to 188 out of 1356, which is a student smoke given that no parents smoke? And then let's compare it to the overall average students smoking in general, 5375. Okay, so remember to show what you're dividing so I can see if it's a valid pattern. Notice how the denominators are changing. So sometimes people accidentally change the numerators but not the denominators. And if you keep the denominator the same, of course, they will be different no matter what. So keep in mind we're using the total row or column in the denominators. So these will always change. They'll be different. So let's go ahead and divide these and see what we get. Okay, 400 out of 1780 is 0.2247. 416 out of 2239 is 0.18579, so 1858. 188 out of 1356. 0.1386. I'm going to move it over to the other side here. 1004 out of 5375. 0.186768. I think we had that one already. That was the first one we found. Okay, so do these seem significantly different to you or not? So remember, we looked at the student smoking. So if we're going to write this out in the symbols, we could say this is the probability of a student smoking given, we're looking at the different possibilities of their parents smoking. Is that close to the overall probability of the student smoking? That's, if you want to write out the conditional statement, that's what it would be like. Okay, so higher is more students smoking, right? And it kind of makes sense that if 2 parents smoke, that's higher. If 1 parent smokes, it's the next highest. No parents smoke, it's lower. And then overall, the 1 parent smoking is kind of like the average. It's pretty close to the average. So these do seem, 13, almost 14%, 18.5%, 22. They seem fairly different, right? And which does seem to make sense given the context. Also, I'll tell you, with a higher number, with a bigger sample size, a smaller difference is significant. And even though we don't have the full tools to evaluate that, I'm going to say these are significantly different. They're not close, okay? The probabilities of the student smoking are significantly different. So they are dependent on whether, or on, let's say, on how many parents, how many of their parents smoke. Something like that. Or you could say the variables, the student smoking is dependent on the parent smoking. Anything along those lines. As long as you get, if they're dependent, they're significantly different. If you say they're close or they're not significantly different, then you could say they're independent. Okay, I hope this practice has been helpful, and I'll see you in the next video.